Okay, so a key challenge in doing assignment 4 is understanding how the BigInt add function should be converted into assembly code. So the basic thing you need to understand is the structures that we're using. So we have a structure called BigInt, which has a length and an array of AUL digits, array of longs of max digits, which is defined here. And then the key function is the BigInt add function, which takes 3 point arguments. These are all references to one of these structures. And then it has 4 arguments that are local. So we have to save space for 7 arguments in this case. And the arguments are going to be saved on the stack in the order they come. This is going to go to the first in the stack, second, third, fourth, fifth, sixth, seventh. So if you look at the structure of how this will look like in the stack. So when we have that structure in the stack, we have, for example, when you call that function, so when you call the BigInt add function, and BigInt add function will create the stack frame because it needs 7 variables, and it puts the first argument, second argument, sum, carry, and these are all uninitialized arguments. And these are all initialized argument because you are going to get some addresses from the main program when you call the BigInt add. So we have 3 initialized arguments that come as function parameters and 4 uninitialized arguments. A total of we have 7 variables, and it takes 56 bytes. Now the stack, these are pointers to some structures whose memory is allocated from the heap. So when you create a new of these things, new structures, you get a new record. So you have a length field in that record that's like 8 bytes. It's long, and then you have an array of that many things, AUL digits. So that's a key thing there. And the other arguments, argument 1 and argument 2, look the same. So this is the sum. This is first argument addendum 1, addendum addend 2, right? So these are the 2 arguments. So let's think about how, so we are really in the same memory, but we have stack area and the heap area. And obviously the register stack pointer contains the beginning top of the stack of the stack frame for the function BigInt add. Now, so key thing to understand is how do we access something like this? Now, if you think about this, this one probably has 2 dereferencing operators here, 2 things that you have to dereference. So what this is trying to do is to get to the addend to AUL digits of 2. So if you think about that, again, if you look at the picture, then I want to, first of all, I want to get to this, that's addend 2, and then I want to get to AUL digits 2, which is this one here. So the question is, what is the code that we need to write to access that element? So that's what we're going to talk about next. All right, so let's start with some examples of how we can answer these questions. Find the address of the element O_1 arrow I length. So this is O_1, which is a pointer to a structure, and the I length is the first field of that structure. So what we are really looking to do in this with this question is to find this address here. That's the address we're looking for. Where is this location? So the question is, how do we start from RSP and get to that point? So let me write a series of steps to do that. So let's say that we want to get to addend 1. Now we know the RSP contains the top of the stack. Now if you count the number of things from the top of the stack, you have 8, 16, 24, 32, 40, and 48. So if you add 48 to RSP, so if you take 48 and RSP, that gives you this content. So if you get to 48 RSP, which gives you the address of the first element. So this is really what you will need for this part here. So what we can do is we can say move Q 48 RSP into some register called RAX. So there's you got the address of this thing here, right? And so the next thing that you want to do is that you want to find the content of that address. In other words, what's in here? What's the number in here? To find the content, because we know now the address is in array_x, so to find the content, all you have to do is to dereference that. So if you want to put the content into some register, you can do that by, we can do that by doing something like this. Let's suppose you do that step first, and then what we can do is we can dereference the array_x, and move it to array_x. So at that point, array_x contains the content of the length. All right, so let's take a look at a few more examples of how we take a structure like this and find out how to refer to particular or specific elements of this. So in this case, we are looking at an array element at the 5th index. And in this case, we are looking at some sort of an array, again, array element, but we are trying to move number 12 to that location. And in this example, we have, let's assume that we have a function called foo. We're going to provide an address in this case, and some number, and perhaps another number here, which would be the length, to accomplish what we want to do here. So the goal of this specific part is to show you how to think about these things. So first of all, if you want to go to add n2, or add n2, we start from RSP, which is this is RSP 0, 8, 16, 24, 32, 40, and add n2 would be at 40. So if you want to refer to that location, what we're going to say is we're going to say, okay, so 40, and obviously we want to use some sort of a displacement or some sort of a macro text instead of number 40. And you know how to do those kind of things. So if you want to refer to the content at that location, in other words, what's in here, or add into this address here inside, it's 99010. So if you want to refer to that, that's how you get it. That 99010 is the addend 2, which is really this one here. So we got the address here. All right, so what we need to do is now to get to the AUL digits 5. So how do we do that? So what we have is the base address of something, of that structure. So let's assume that that's the base address. So this would be the base address. So what we're going to do is we're going to move this base address to some register. Let's move it to array_x. And now we have to move, let's move 5, the index 5. So let's say move q immediate 5 to, let's say, R10. Then we have to do, so we have that. And so what we can do is now to think about how to compute the 5th element of this thing. Now, as we know, this AUL digit starts 8 bytes from this base address. So it would be 8 bytes because the length takes 8 bytes. So what we can talk about is that 8 would be the displacement, and the base address is array_x. And then you have R10 contains the actual index, which is the immediate 5, and then 8 is the size of a long. So with this, we refer to the content at the address O addend1 AUL digits 5. So if you say move q 8 array_x R10 8 to array_x, at the end of this segment, array_x gets the content of the this what we're looking at. So note that I kept reusing array_x register. So I had to do 2 dereferences to get there. Starting from the RSP, I got to the right location for the addend1, which gave me this address, and then I found what I'm looking for by
using this indirect addressing. So if you want to do something like this, it says move number 12 to that location. So what we can do is we can write a piece of code like this: move Q. We want to move number 12 to this location here, which is, we already computed that, assuming that you have done the ones before that. So here we have done, so we're moving number 12 to that. Obviously, these are all lowercase things. So these are all lowercase here. All right, so finally, let's see how we can do the other one here, the last one, which is calling a function with a certain argument. So next, we consider the case of calling a function. Let's say that you want to call the function foo with the arguments, three arguments in this case, OADN2 AUL digits, which is an address, not content, and the number 10, and then some other number, OADN2 I length. So we need to write code to find each of these things and put them into the right registers so we can call the function foo. So how do we do that? So let's think about what we did before. So for example, how do we find OADN2? As we know, we define the offset from the RSP. This is 0, 8, 16, 24, 32, and 40. So 40 is where the OADN2 starts. So if you refer to 40, obviously, again, you want to use some sort of a text description to describe 40. That could be OADN2, like we've seen before. So what we can do is we can move Q. Let's move Q to a register. So let's move that to a register. Now, since what we're trying to do is to get this one here, right? So since we are using the register RDI for our passing our argument, first argument to a function, I'm just going to move it to RDI. And then, so what that gives you is the content at that address, OADN2. That's the starting address of the addn2 record. So what I really need is the starting address of the array, which I know is from 8 bytes from that, because the length would take the first 8 bytes. So what I can do is I can say add Q, let's add 8 to the RDI. Now at this point, RDI contains the address, this address here. So we took, so for example, this 40 RSP would be the address here, and then we added 8 to it to get to here. So now we have the first argument, which is an address. So the second argument is placed in RSI, which is number 10. So what we're going to say is, so we're going to say move Q number 10, immediate 10, in RSI. This is the second argument. The third argument is a length. So we have to get to OADN2 and the length, right? So we know this is how we get to OADN2 content. So what we have to do is to, let's start looking at the content. So if you look at RSP, and so what I need to do is to move it to a register. So since I'm going to use the register RDX for the third argument, what I'm going to do is I'm going to say move Q for the RSP, which referred to the address of OADN2, which is this one here. This is also the address of the, if you look at the content, that's also the address of the length. So I can't dereference that directly. So what I will do is I will move this to RDX, which is my argument 3. And then, but RDX now gives me this address, 9900010. So next, what I'm going to do is I'm going to say move Q, look at the content of RDX, which referred to the length, actual length, which is this number here, whatever that length is, and then move it to RDX. Once again, note that I'm keep reusing the same registers. Sometimes I dereference and put the content. So in some cases, the register contains an address, and in other cases, it contains the content. Like for example, this one here, these two statements, in the first instance, I dereference to get an address of OADN2. So at this point, RDX contains an address of the length. But then when I dereference that address, I am going to get the actual length, which is in RDX. Now at this point, I have the first register done. So it's the content is there. Here's the second register. In fact, this one here, this is where the right content is. Let's not do that. Okay, and then at this point, so this is where these are the instances of the registers have the right content, so I can call the function called foo. And so it's a demonstration of how I can call a function with 3 arguments by sending, by getting the right things based on the picture I have.